Good morning or afternoon or whatever it is when you're watching this. Machado here, and I am going to be looking at Chapter 11, Section 1 today. This is the only one that we're going to do out of this. After that, we're going to do just a bunch of review stuff and then get ready for your final. So, Chapter 11, we've got a couple of things that are review, and then we've got a new idea looking at some circles, which is going to be some fun. So, the first thing that we want to look at is the distance formula. Now you looked at this briefly in Math 1, but it's been a while since we've used it. The distance formula looks like this. D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And this is to help you find the distance between 2 points, which would be x1, y1, and then x2, y2. Okay, so those are your 2 points. This is the formula that we use. The way that this works is, I'm going to take a graph here real quick just so you can kind of see. Because in Math 1, you don't really use the distance formula that much. Instead, what we did was we said, okay, here's 1 point, and then here's another point. And I want to find the distance between these 2 points, right? I want to find the length of that line segment. And so this point is 4, 2. This point is 1, 2, 3, 4, 5, 6. 1, 6. So those are my 2 points, and I'll show you how to use the formula as well. But in Math 1, we looked at the slope triangle and said, okay, well this side is 4 and this side is 3. And then we just used the Pythagorean theorem to figure out what my distance was. So I know that 4 squared plus 3 squared equals d squared. So that's 16 plus 9 equals d squared. 25 is d squared, so I have to take the square root of both sides, and I end up with a distance of 5. The same thing works here. It really is truly the same thing as what's going on right here, except for rather than having to draw a picture and figure out these distances by counting, we use subtraction to figure out the distances. So I'm going to have my 2 points be 1, 6, and then, not 2, 4, 4, 2. And then I can plug them in. So the distance is going to be equal to the square root of x1 minus x2. And it does not matter which one you put first. You could have it be 4 minus 1 or 1 minus 4. All that matters is that you're subtracting them and you pay attention to your signs. Remember with slope how those double negatives really mess everybody up? The same thing is happening here. You want to make sure to subtract them. And if you've got a double negative, it turns to a positive. And then I've got 6 minus 2. And because of the way that this works, because they're going to be squared, you don't necessarily always have to have this one, and then this one and this one. You could go this and this. It just, as long as you're finding the difference between those two numbers, you're going to be fine. Because then we square them and we add them up. So any type of sign change is not going to make a difference. So this is going to be at negative 3 squared. This is going to be 4 squared. And I end up with the square root of 9 plus 16, which is the square root of 25, which is 5. Okay, let's look at another one that might not be quite so nice, just so we make sure we've got a good example here. Let's say I've got brain work. Negative 2, 3, and then 4, negative 5. And I want to find the distance between those 2 points. So I'm going to plug it into my formula. I've got x1, y1, x2, y2. And so I'm going to have negative 2 minus 4 squared plus 3 minus a negative 5 squared. Oh, negative 5. And parentheses and then square. So with these ones, we have to pay attention to signs. These are the little mistakes that really get you with the distance formula, or really with any formula. So this here is going to be a negative 6 squared. This, I've got a 3 minus a negative 5. Well, that's going to be a plus. So I've got 8 squared. And so I've got 36 plus 64. Oh my gosh. Okay, I was going to have one that came out not nice, but I made it up, and look, it worked. That's pretty awesome. So the distance is going to be 10. If it's not a perfect square root, then you just simplify the square root like we have before, where you take out any perfect square factors. Okay? So there's your distance formula. The next one that we're going to look at is midpoint formula. Get my paper in the right spot. There we go. So midpoint. I'm going to use that same picture that I had before, because once again, midpoint is something that you did look at in Math 1. You may or may not have actually looked at the formula, and you probably haven't used it a lot since. But if I'm looking at this line segment right here, and I want to know what the midpoint is, I'm looking for this halfway point. And if I have it graphed, I can what I can do is I can cut my slope triangle in half, right? I can go over, instead of going over 3, I'm going to go over 1.5. Instead of going up 4, I'm going to go up 2, right? And I can really just find it by cutting that in half. So what we're going to do is we're going to take the average of these two numbers here and the average of these two numbers here, so that I can get the halfway point between my y's and the halfway point between my x's. So let's see what that looks like in terms of a formula. Oh, it's all sideways, sorry. So the midpoint formula looks like this. The midpoint is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So we really are just finding the average between those 2 points. So using that same example that I had before, 1, 6, and then 4, 2, I'm going to go ahead and take my first one. I've got 1 plus 6 divided by 2. And then for my second one, oh, not 6, sorry, 1 plus 4 divided by 2, right? Got to make sure you get your x's. And then I'm going to have 6 plus 2 divided by 2. And so this gives me, this is 5 over 2. And then this is going to be 8 divided by 2, which is 4. Or, just so we can see it on the graph a little bit easier, 2.5, 4. Now if I look at my graph, notice this point right here, if I go over 1, 2.5, and then I go up 1, 2, 3, 4, I end up right exactly where that midpoint is. Okay, I'm going to use the same example from earlier, the second one there with the negatives, just because we want to make sure to pay attention to negatives as we use these formulas. So -2, 3, and then 4, -5. So I've got, for my first coordinate, I've got a -2 plus 4 all over 2. And then I've got a 3 plus a -5 all over 2, right? In this case, I've got opposite signs, so I have to make sure that even though I'm adding them together, I'm paying attention to integer rules, and these are actually going to end up being subtracted, right? So I'm going to have a 2 over 2, and then this is going to be a -2 over 2, which gives me a coordinate of 1, -1. Let's graph this real quick just so we can kind of see and make sure that it works the way that we think it does. Okay, so bonk, bonk, graph, and graphity graph. Okay, so my first one is -2 and then up 1, 2, 3. And then my next point is over 4, and then down 1, 2, 3, 4, 5. And draw my pretty picture. And then the midpoint ends up being right here. And if we look, if I was to draw that slope triangle, if I wanted to look and see what my distances look like, notice it has the same slope triangle on each one. So it looks right and it works. Okay, so those are the first couple of problems. I'm going to pull this over here so you can see it. If you look at these first ones, they're asking you to use just the distance formula. Just find those. It says to round it to the nearest tenth if needed. If you want to leave it just an exact form, I'm perfectly fine with that. And then for the midpoint, they want you to find the midpoint and then plot the endpoints and the midpoint on the graph, kind of just like I did right here. Okay? All right. Right now I would say any questions? Any questions? Yeah. So the next thing that we're going to look at is a circle. And I know that you know what circles are. You've seen them before, but we haven't really graphed them before, and you haven't looked at what they look like algebraically either. So that's what we're mainly going to be looking at today. So we have the equation of a circle. And a circle is a little bit different because it's actually not a function, right? If we remember, if I have a graph of a circle, I'm just gonna, this is gonna be a really bad circle, so don't judge. That's not a circle, but suppose it is a circle. If I'm looking at this, this is not a function because it does not cross that vertical line test, right? You've looked at circles quite a bit anytime that you've looked at, is this a function? They always throw circles at you. And you'll notice that the equation of a circle is quite a bit different too. So just the very basic equation of a circle looks like this. X squared plus y squared equals r squared. R stands for the radius. Okay, so that's the radius of the circle. So this circle is actually going to be centered at 0, 0. And so if I wanted to give you one to kind of graph and play around with just to start, I could say something like if I've got x squared plus 3 squared equals 16, right? I have to look at this and determine what is my radius going to be. Well, 16 is equal to r squared, so 4 is going to be my radius. We'll look here in a minute where transformations come in, but just for this very first one, this one is centered at 0, 0. There's nothing weird going on this side, right? If I've just got an x squared and a y squared, nothing weird. So it's centered at 0, 0, which is also known as the origin. All right. So I know that I have a radius of 4, so I'm going to go out 1, 2, 3, 4. Like this is going to be my center right here. I'm going to go out 4, and then I'm going to go out 1, 2, 3, 4. 1, 2, 3, 4, and then go down 1, 2, 3, 4. And then in order to kind of sketch a circle, remember it's a circle, so we don't want to just draw a straight line between there, right? We want to kind of sketch it. I like to turn my paper to try and make it look as circular as I can. If you have a compass, you can use one of those too, but my guess is most of you guys don't have it, so I'm not going to use one. I'm going to have circles that are circular-ish. I want to match the stuff that you guys have at home. If you have a compass, that's super awesome. Let me grab mine so I can show you how it works. Oh, there it is. I knew it was in there somewhere. If I wanted to use my compass, let me get this. So remember, this is a compass. It's used to make circles and arcs. If you've got one, great. If it's not necessary for you to have one, but it is kind of helpful if you want to draw a circle. So what you would do is you would put the tip of your compass right here, and then the part where it's going to draw out here. And then there's a couple of ways that you can do it. You can do it by kind of turning this piece around. Oh yeah, see, that's way off of circular. That is. Right, so you can turn this piece around like that to draw a better arc. Some people like to turn the paper like this and have it draw like that. Oh yeah, my circles are cruddy. Look at that. Isn't that pretty? So I'm going to erase all my yucky stuff there. In terms of graphing these, I'm not going to be super nitpicky, right? You guys know that. Just graph it as best you can. If you have something like a compass, awesome. If you don't, just do your best, right? It doesn't have to be a perfect circle. So with this, you notice we figured out what our center was, and then we figured out our radius, and we went out 4 units in every direction that we could and went from there. If you wanted to try to make a better one and you didn't have a compass, what you could do is you could mark that length here, and then you could use this to give you some markings, you know, at your points across here, so that you have kind of like a little bit of a measuring tape to give you a little bit of a way to mark some spots and then connect those dots. So this is the very basic form of a circle when it has a center of 0, 0, and just your radius is r squared. So if I wanted you to write the equation of a circle, and I tell you that the center is 0, 0, and I tell you that the radius is 7, we're going to use this idea right here in order to write the equation. So I know that I've got x squared plus y squared is equal to r squared. They told me my radius is 7, so that's 7 squared. X squared plus y squared equals 49. Okay, so those first group of them are pretty basic. The next ones, we start to look at the idea of, well, how can it be transformed? We looked at transformations with parabolas. So let's look at that again real quick. Parabolas, parabola. And we had graphing form, which was f of x is equal to x minus h squared plus k. Right? And remember, h was your horizontal and then k was your vertical. So these h and k's, they really told us what to do, which was pretty helpful. When we're looking at the equation of a circle, because remember, all that this did was this shifted our vertex, right? It was graphing form or vertex form. So it took the vertex of that parabola and it moved it around, right? It could move it back and down, it could move it over and down, and then your parabola would be right here, right? That was the whole idea of these transformations. With the circle, the center is what's going to move. So let's look at that. If I've got, this is, not a y. I don't want to start with a y. Okay. If I've got standard form of a circle, it's going to be x minus h squared plus y minus k squared equals r squared. This is standard form of a circle. Okay. This one, it shows us where our center is going to be. It also tells us the radius, so that makes it really easy to graph it. All I have to do is move my center to whatever point this dictates and then graph it from there. So let's say I've got this one right here, x minus 3 squared plus y plus 2 squared is equal to 4. If I'm looking at this, I know that my r is 2, okay? My h, right, because this is x minus h, so my h is going to be a 3. That's going to be my first coordinate. Remember, it's the opposite of what's in here because it's subtraction, and because this is inside of something, it's also going to be the opposite. So this one, it's a minus 3, so I have a positive 3 here. This is plus 2, so there's my minus 2 for my center. Okay? If I want to graph this real quick, I'm just going to I found my center and I know what my radius is. So from here, all I have to do is draw my graph. I'm using a way bigger graph than I need, but that's okay. I'm going to go over 3 and then I'm going to go down 2. This is the center of my circle. And I have a radius of 2. So it's going to go 2, 2, 2, 2. And if you want, like I said, if you've got a compass, great. I might try and use it a little bit more, just because I don't know, I haven't used these in so long that I'm kind of rusty at it. It's kind of wobbly for me, and I don't really like that. I like to be better at things, so I'm going to try. It's fun. Look at that circle. Right, and once again, you're at home. You might not have a compass. That's okay. Just do your best and make some circles. When I did the work, because I'm going to upload mine, just like I did for the last stuff, my worked out answers, you'll notice my circles don't look like this because I don't have a compass at my house. Why? I don't know. I should have a compass at my house. Okay, so from this one, let's just look and review what we did to get there. Here was the equation that we were given, and we had to figure out what our radius was, right? Remember, it's equal to r squared, so I had to take the square root of 4 to get 2. And then here, I had to look at the opposite of whatever these numbers were to get my x and y coordinates of my center. Let's do another one. Let's say I've got x plus 4 squared plus y minus 1 squared equals 25. Okay, so here, I've got my x coordinate is going to be a minus 4. Remember, it's the opposite of whatever's in there. This is going to be minus 1, so that's going to give me a positive 1 for my y. And then my radius is equal to 5, right? Remember, I get my x and y from here, just the opposite of those signs, and then I take the square root of that to get my 5. Now, if I want to graph it, this is going to be a bigger graph. So I've got a radius of 5. So I'm going to go back 4, 1, 2, 3, 4, and then up 1. So here is my center, -4, 1. And then my radius is 5, so I go out 5 in each direction. Now 5 is a fun number because it's a Pythagorean triple, right? Or it's part of a Pythagorean triple, 3, 4, 5. It's that hypotenuse, 1, 2, 3, 4, 5. So I can actually even go out 3 and then up, 1, 2, 3, 4. And I can go 3 and then over 4. And notice I can get a couple of extra spots along my circle here. 3. And you don't have to do that, right? You can just do your best to get it to be 5 across. But when you've got those extra ones out there, notice that you can connect them a little bit easier. And it looks a little bit more circular than the junk that I normally put together. Wait, that's not right. 1, 2, 3, 4, 1, 2, 3. No, from here. 1, 2, 3, 4, 1, 2, 3. There we go. I knew that didn't look right. I was going from the wrong point. Right, and just take your time. There's no rush, right? Pretty circle. Okay. You might also be asked to write the equation of a circle given certain constraints. So if you know that the radius is 6 and that the center is, let's go with -2, -3. Well, I know that I've got x minus h squared plus y minus k squared is equal to r squared. So I can just take these pieces and plug them in there. Sorry, I bounced it. So I've got, this is my h, and then this is my k. So I've got x minus a -2 squared plus y minus a -3 squared is equal to 6 squared. I'm just plugging in the information that I was given. So I've got x plus 4 squared. No, not 4. Why did I get a 4? That was weird. X plus 2 squared. And then I've got y plus 3 squared is equal to 36. There you go. The last ones that we're going to look at are, we might have to put them into graphing form. And that's a little bit more tricky because if you remember when we did transformations with parabolas, we sometimes had to put them into that vertex form to be able to easily see where our vertex was. Well, same thing with these, and the process is going to work the same. We're still going to be thinking about completing the square, figuring out what we have to add. The part that's a little bit easier with these is that we don't have to do the add and subtract. We can actually just add it to both sides. So let's look at one of those and see how it works. So let's say I've got an equation like this. X squared plus y squared plus 2x plus 6y plus 9 is equal to 0. So looking at this, I know it's going to be a circle because I've got an x squared and a y squared. And I've got this x and y thing here, and then I've got this 9. So what I'm going to do first is I'm going to move my 9 over to here, and then I'm going to group these together with their terms. So I'm going to rewrite this as x squared plus 2x, I'm going to leave a space, plus y squared plus 6y, I'm going to leave a space, is equal to -9. Now, in order to turn this into something that looks like this, with an x plus or minus something squared and a y plus or minus something squared, I have to complete the square here, complete the square here, and then whatever I do on one side, remember I have to do it on the other too, okay? Because I have to keep my equation true. So here, remember, if I'm completing the square, I take b divided by 2 and then squared. So that's going to be a 1 squared. So I add 1 to the other side. Here, I've got 6 divided by 2 squared. That's going to be 3 squared, which is 9. So I've got a 9 and a 9. Okay? So now I can take this and I can regroup this and I can factor it. This is that perfect square trinomial. Remember, we engineered it to be a perfect square. So I know it's going to be x plus 1 squared, and then I've got y plus 3 squared is equal to, on this side, I get 1. Now when I look at this, I can see my center for my circle is right here. I've got a center of -1, -3. Remember, the opposite of what's in here. And my radius is the square root of 1, which is just 1. So that would be a quick and easy one to graph. Okay? I'll give you one more example of those just so that you can kind of see it one more time, because that's the tricky part of these. There's only 4 of these in your assignment, so I'm doing a few of the odds. Remember, your assignment is only the evens. All right, I've got x squared plus y squared minus 4x plus 10y minus 7 equals 0. So once again, I'm going to get this into that nice pretty form so that we could find our center and radius and then graph it afterwards. Once again, moving that 7 over and then regrouping. And so, you know, if you want, you could even do that as you write the problem down. Just pay attention to signs. Make sure you don't miss anything, right? Plus blank, and then y squared plus 10y plus blank equals 7 plus blank plus blank. Right? It is really important to pay attention and make sure that you're doing it to both sides. And having those lines there for me to put the things that I'm adding onto makes it really easy. So here, I've got -4 divided by 2 and then squared gives me 4. 10 divided by 2 is 5. Squared gives me 25. I've added a 4 and a 25, so I've got to do it on the other side as well. Here, I've got x minus 2 squared plus y plus 5 squared. And then over here, I've got 2936. Okay? Now, once again, I can really easily see my center is the point 2, -5, and my radius is 6. Once I have those pieces of information, a circle is something that's pretty easy to graph. Okay? Let me know if you have any questions. Remember, I'm available. Email me, text me, whatever you need to do. Let me know if you need to come in and if you have any questions. I hope this goes well. Adios.